Hi, my name is Samuel Vargas. I'm a WebGL intern here at Mozilla for summer 2017, and I'm doing my intern talk about how I contributed to improving WebGL's performance and the amount of conformance we had to the WebGL conformance tests. So just a little bit of background about me before I start. So I'm a senior at Arizona State University right now, majoring in informatics. I've always been interested in graphics programming and systems programming. It's my first time as an intern here. I'm really excited about that. You can see it gets very hot in Arizona. I didn't make that number up. It's real. But anyway, my goals this summer were to improve the level of conformance we had, just overall performance, and then fixing real-world bugs that users were running into pertaining to WebGL. So yeah, this is just kind of a recap about it again. So conformance bugs, miscellaneous tracking, and in the wild bugs. So first I should explain what WebGL is. So WebGL is an open standard for creating graphics accelerated applications. So what that means is basically any kind of interactive 3D program running in the web browser. And it's powered using a technology called WebGL, which is a derivative of OpenGL, which is like an API for making cool graphics. So the implications of this are that it allows us to create high-speed interactive programs without using proprietary or platform-specific plugins. So a lot of uses for games, but also practical for non-game uses as well. Google Maps, for example, if you zoom all the way out, it actually switches over to like a globe view, and you can rotate that. And that's a real-world example of using WebGL for a non-game application. So WebGL is a lot different than APIs that most people are accustomed to. So if you weren't familiar with graphics programming, you might think that rendering a scene on the computer might be as simple as basically saying, oh, I want a cube, I want you to make it yellow, put it over there, I'm done. But it's more like you call a series of functions that expect inputs and outputs in the correct order. WebGL does something with them in a gigantic state machine, and then you get your picture out at the end. So it's very procedural, but it makes it well suited for binding to multiple languages, since there's no like language-specific features in the API that would be difficult to implement elsewhere. So a conformance test is basically a series of instructions in WebGL that tests that Firefox implements the standard correctly. So something like painting a picture on the screen using multiple attachments in the correct order. So if our implementation of WebGL didn't do that correctly, somebody developing a WebGL application, it might work well in like Microsoft Edge or Google Chrome, but when they go to Firefox, they might have like this weird specific bug because we're not testing something correctly in WebGL. So the entire point of the conformance test is to make sure that when people use WebGL in Firefox, it behaves like it's supposed to. So it allows us to basically prevent future bugs and ensure everything works correctly. So the left image is what it's supposed to look like, and the right image is an example of some tests that fail. And then they highlight the specific functionality that didn't pass the test. So I didn't know anything about conformance tests when I started initially here, or dealing with large code bases. I'd only worked on personal projects and stuff for school. So it was definitely a shock, but I feel like I learned a lot. So ultimately what it boiled down to was I would pick a failing test from the conformance test suite, check that against the official WebGL standard. And this part was really important because there are multiple times where we would find a test. I would spend like an hour going through it, trying to make sure that it was working correctly, and then go through our implementation, trying to find the bug. And then I would talk to my mentor, Jeff, and he would say, oh, you couldn't pass that test anyway, it's impossible. So make sure the test is good. Reducing it to the smallest portion possible. So a lot of times it's not the entire test that fails, it'll just be like 6 or 7 function calls in it out of 100. So if you narrow it down, it makes it a lot easier to trace where that behavior initially goes wrong. Then you would just use standard debugging tools, Visual Studio Debugger, GDB, etc. write a patch for it, review it. That was kind of an iterative thing until we got it working, and then submit it. And then you can see the simplified version on the right. So one of the biggest things I took away was that so basically my old tools in development methodology for writing programs didn't really scale with Gecko. I'd used GDB before and Git and Vim and all of that other stuff, but not to the extent that people use it here at. So I was really grateful that I had this gigantic code base that forced me to actually dig into how these tools worked. Otherwise, I would have never gotten past my first bug. So in particular, GDB, I mean, I know how to set breakpoints and stuff, but I didn't realize how many extra commands that were in there to learn more about whatever the bug was at hand. So things like using set, for example, to force behavior and jumping past asserts and stuff like that. Like, it had never occurred to me to even try that before. Git I've used previously in the past, but Jeff helped me a lot with like advanced Git functionality. Like, I didn't know anything about work trees or advanced rebasing or anything like that. So it was really cool to get that real world experience with this version control tool. And then new tools. So Cocoon is a text editor a friend of mine is working on that's really great for like batch, search, and replace. So there are a lot of times I had to do jobs like that, and it sped things up. FCF is Fuzzy Finder. I use that a lot for jumping between stuff. And Silver Searcher, which is like a faster version of grep. So I learned a bunch of new tools in my short summer here at Mozilla out of necessity, and it was a great experience. But in short, the biggest things when you're working on these tests are use pen and paper, always reduce it to the smallest element possible. Nothing in it is magic, and that took me a long time to realize. Like, it becomes difficult to trace something down, and you might think that there's no reason for it, but there's always some specifically enumerated rule in the specification explaining what's going on. So always check the standard, and then just take advantage of your debugger, like really learn how to use it. So I worked on other things in addition to conformance tests. So there were bugs that users had experiencing WebGL, or things that we could have modified in WebGL that we did to improve the performance of it. So a specific one that's kind of cool is this web framework that this guy worked on called Arroyo, which is a creative coding framework that has a WebGL backend. So you could code in C++ and compile it to WebGL and then run that in the browser. Specifically, he was using a technique called instancing, which is where you draw one object and then you tell the graphics card that you want to draw many, many, many copies of it. And instead of wasting memory or time doing it all over again, it just says, oh, okay, sure, I already have this data, and it just duplicates it for you. So in that picture, there's like 1,024 dragons, and it runs super fast, even on mobile devices. But anyway, on Windows, when you tried to visit this page, it would just crash completely. But it worked on all the other platforms we tested. And eventually, we narrowed it down to a bug in a library we used called Angle, which converts OpenGL calls to DirectX calls on Windows for improved performance. And essentially what was happening was that a 0 was being passed into an argument instead of a 1. So the 0 basically told Angle that instead of one instance of a dragon being rendered, there was no instancing going on at all, which was causing some like sanity checks in it to fail, causing the page to crash. So we were able to fix that and patch it and land it by using all the aforementioned tools that I worked on. So that was really fun to work on. And then another thing I got to work on was something called compressed textures, so S3TC sRGB. So textures in computer graphics and in WebGL are just 2D images that we wrap around 3D objects. So in the example over there, you can see if you wanted to put this checkerboard image onto a cube, eventually you have to start with a flat image at some point. So the far left would represent the image before it gets wrapped, and then the right is after. So texture compression allows us to upload more textures to the graphics card, and by using less RAM, basically, by compressing them in video memory. So this one is really hard to work on too, but there are people who actually wanted this, Unity in particular. So now when game developers are targeting WebGL and they want to use this specific feature, they don't have to feel like they're not allowed to use it because one of the major browsers doesn't support it. So that was rewarding to work on as well. So ultimately, I mean, the biggest things I learned about OpenGL was that so I've only used OpenGL in like a hobbyist sense basically before I started here. Like I never worked with it in a professional capacity. So it was really cool to get experience working on it like in a real world application where things don't always work and we have to support multiple configurations, not just your own computer. How to work comfortably with a large code base. I'd never done that before. So that was really cool as well. I feel like now if I work somewhere else or if I have to deal with another large code base, I'll have like a point to start at. Asking for help the smarter way. Initially, I was really hesitant to ask for help because I felt like, oh, I could figure this out, or I don't want to bother my mentor, or stuff like that. But a lot of times, the problems you're dealing with, there's no way you're going to know. Like there's a lot of scenarios where I would implement something and he would say, oh, we don't need to do it like this for this legacy reason, or whoops, that legacy reason. And yeah, finally, and then I guess working with a team to basically ensure that your product works. I haven't done much team development before, and it was good for a change of pace. I'd just like to give a special thanks to my mentor, Jeff, for being so approachable and helpful with WebGL. I wouldn't have learned anywhere near as much if I had just tried to do it on my own. Milan, basically everyone on the graphics team, and everyone else at Mozilla. It's just such a great atmosphere, and I was really grateful that I had the opportunity to intern here. And that concludes my presentation. Does anyone have any questions? Thanks. If not, thanks.